Hello and welcome to another Algebra 1 video tutorial. In Lesson 10.6 we'll be looking at systems and parallel lines. The big idea would be systems having 0, 1, or infinitely many solutions, corresponding lines having 0 or 1 point of intersection, or being coincident, meaning they're the same line. Okay, so the big idea behind parallel lines is that they go in the same direction. You know what they look like. So we call two lines parallel if and only if they are in the same plane and are either the same line or they do not intersect. All vertical lines are parallel, so are all horizontal lines, you knew that, but not all oblique lines are parallel. For oblique lines to be parallel, they must have the same slope, same rate of change, same slope. The slopes and parallel lines property just says if two lines have the same slope, then they are parallel. Okay, so this is probably information you already knew. Let's consider the system 5x minus 2y equals 11 and 15x minus 6y equals negative 25. Right away, these are in standard form. We cannot tell the slope right away very easily, so we don't know if they have the same slope or not. So what we want to do is try and solve this system or get them to both be in slope-intercept, whichever is easiest. So let's say we want these to be 15 is a multiple of 5, so let's try to get these to be opposite. So I just multiply the top one by negative 3 to make this a negative 15x. So doing that, the top equation now becomes negative 15x plus 6y equals negative 33. So that one changed, the bottom one will not. 15x minus 6y equals negative 25. Now I have a pair of opposites. So what I'll do is I'll go ahead and add these two equations together. Negative 15x plus 15x is 0. 6y minus plus or minus 6y is 0. So I end up with 0 total on the left side. And then equals negative 58. Well, what happened to the variables? Well, they both canceled. And we ended up with a false statement, which meant that the original two equations, there were not a pair of xy values that work for both. So this is a case where there is no solution. No solution, meaning these would be parallel lines and they would not intersect. So if we were able to graph these, either put them in slope-intercept or just getting the x and y intercepts to graph these, we see that they are parallel lines and they will not intersect. So they're parallel non-intersecting, which means no solution. There's not a pair of xy ordered pairs out there that will work for both, so no solution. All right, solve the system x plus 5y equals 7 and negative 10y equals 2x minus 14. Now this isn't set up for substitution or the elimination method, so we'll need to rearrange this first. It's pretty easy since the last section we learned was to use the elimination method. Let's just subtract 2x from both sides and get a new system. The top equation we won't need to change. X plus 5y equals 7. The bottom one now just became minus 2x minus 10y equals minus 14. To get these to be opposites, let's get the x's to be 2 or the y's to be 10. Either way, see what happens. Probably multiply the top equation by 2. So doing that, now the top equation becomes 2x plus 10y equals 14. Bottom equation is the total opposite. So when we happen to add opposites, we end up with 0. So we get 0 plus 0 equals 0. What this means is these are the same lines. So there's infinitely many solutions. So any ordered pair that works on one line will work in the other. So there's infinitely many solutions. Okay, now the other thing a guy could do is solve both of these for y, get them in slope-intercept, and show that they have the same slope. So let's do that real quick. You don't have to once you've solved this, but there's another method here too. So we'd end up with 5y equals, so we'd subtract x from both sides, then divide by 5. So I end up with y equals negative 1/5 x plus 7/5. Now with this other equation, negative 10y equals 2x minus 14. We just need to divide both sides by negative 10. and I end up with y equals 2 divided by negative 10, that's going to be negative 1/5. Negative 1/5 x. And then negative 14 divided by negative 10. We could reduce that to positive 7 fifths. Okay, which shows that these are the same exact line. They're the same line. So they're coincident lines is what we call this. They're the same line, which means there's infinitely many solutions. So any ordered pairs that is on this line is a solution. All right, this will be a good one for you to try on your own, just to see if you get the concept here. So pause the video if you want. Find all the solutions to 12x minus 30y equals 12 and negative 8x plus 20y equals negative 8. I'll work this as well if you want to check your solution. Okay, what can you do to get these to be opposites? Well, 12 is not a multiple of 8, so we need to get a common multiple here. So I'll probably make these 24 and negative 24, or make these 60 and this negative 60 and this positive 60. So we need to multiply the top equation by 2, the bottom one by 3. So now our new system would be 24x minus 60y equals 24. The bottom one now is negative 24x plus 60y equals negative 24. We've created equations that are the total opposite, so we get 0 equals 0 when we add them, which means there is infinitely many solutions. They are coincident lines. Now we can solve these for y and show that they have the same slope. It's unnecessary unless you're wanting to graph them and take a look at that. Infinitely many solutions on this one, coincident lines, because we get a true statement, which is always going to work. All right, so kind of wrap this up. What we solved quite a bit before this section is two intersecting lines. There's going to be one solution because they intersect in one spot, and the slopes are going to be different. Now, they don't have to be positive and negative. They could both be positive, but if they're different slopes, they will intersect at one spot. Okay, if we have two parallel and non-intersecting lines, there are no solutions, but the slopes are equal. And then we can have one line because they're parallel and they're coincident, so it appears to be one line because they're actually reduced to the same equation, or would be put in the same slope-intercept equation. So there's infinitely many solutions, but the slopes are also equal on that. All right, that wraps this up. Your assignment will be 10-6, page 619, 2 to 20 evens. Thanks for watching, and we'll see you next time.